How to measure average execution time of a script. I have two scripts that each compute the factorial of a number. I would like to know which is faster. The time command gives me milliseconds and the result is different from time to time. How do I take the average time it take to run the script? I could parse and average out the output of a 100 times, but I imagine there is a better solution.
No, your idea of averaging is correct. Script execution depends on lots of factors, and however it is to be split up between setup time, loading interpreter in memory, setting up, and possibly compiling code to bytecode or machine code, and true execution time. To better focus on inner execution time, you do the loop in the script itself, i.e. instead of calculating 1 factorial, you calculate it 100 times within one execution of the script. The script will be set up once, and the inner routine will execute 100 times. To focus on total time, you execute the script 100 times and average the results. Ideally, you should separate those executions enough that the system returns in a reference state, or a script unrelated state, every time. For example, the interpreter itself will be cached in memory, so that the very first execution of the script will be appreciably slower than the subsequent ones. To get a better insight on the algorithm, I think the best way is something like this, on an otherwise idle machine. Wrap the algorithm in one single function. In the controlling application, call the function once. Get the system, wall clock, time and add 10, or a reasonable in seconds. Enter the loop and start counting iterations. After each call to the function, increment the counter. If the system time is below the save time, do another loop. Get exact n, possibly floating point, from current wall clock time. Display the counter divided by n, that's the number of iterations per second. The application only runs once. All setup and priming is done by the first untimed iteration, so this should minimize the overheads, except maybe for the time call. If the function receives an input, you do well to supply it a random sequence of inputs using a PRNG, seeded with a fixed value, to ensure both versions of the function being tested receive the same values. This avoids one function performing apparently better due to lucky numbers. For example, I remember a variation of the Hillsort algorithm that performed measurably better if the number of items to be sorted was in the form 2k1 with small k's.
You can run iterations of the program in a loop and divide the total time by the number of iterations.
There's a tool called Multitime that does exactly this, running a command several times, measuring how long it takes. Real/user/system with mean, min/max and median time automatically computed. For instance, for measuring a similar script 100 times.
This is old, but it came up so high on Google when I was looking for a command I used previously but couldn't find. Anyways, my preferred way of doing this is. This gives quite a bit of details, including average execution time right at the end.
If you want to support